In this problem, we are trying to solve for x. So I look and I notice that I have a rational expression, or a rational equation, and that I need to find an LCD. So my LCD for 4x, 8, and x is 8x. Now, since I have an equation, I can multiply both sides of my equation by that LCD. So I can use 8x over 1 on both sides. I'm going to write that 8x over 1 next to each of these fractions because I'm basically distributing it to both fractions on the left side. So now we can get to canceling. If I cancel, my x's cancel here, and my 4 and my 8 reduce down to 2. On the next set of fractions, the 8's cancel, so the x is left, and on my last fractions, my x cancels, so the 8 is left here. Looking through the problem, I'm going to multiply out whatever's left. 2 times 1 is 2. Notice the denominator is gone except for a 1, which we don't need to write. Then all I have left here is negative 3 times x, so negative 3x. And here I have negative 6 times 8, which is negative 48. I have a nice linear equation, easy to solve, so I'm just going to subtract 2. And divide by negative 3, giving me an answer of 50 over 3. Some of you were using an alternative method for this problem, so I just want to show that as well. So some people were taking the LCD, which is still 8x, and they were creating the 8x on each fraction. So this is multiplying by the missing factors to get to the LCD. So my first fraction would get multiplied by 2 over 2, giving me 2 over 8x. My second fraction would get multiplied by x over x, giving me 3x over 8x. And my fourth fraction is missing the 8, so I'd multiply by 8 over 8, giving me negative 48 over 8x. At this point, we could multiply, or we would need to multiply by that 8x over 1, but the simplification process is a little bit easier since they're all just going to directly cancel. So if that's a preferable method to you, you can also use that method to solve. So we would use the same steps, subtract the 2, giving me a negative 50 on the right side, and then divide by negative 3, giving the same answer of 50 over 3.